Yeah, good evening, students. I hope you have written your test well. Let us discuss today's paper, AIMTS physics paper, date 3rd of September. Yeah, coming to the first question. What is given here? Vector A is perpendicular to B, component of A vector minus B vector, and A vector plus B vector will be. Yeah, vector A is perpendicular to B. So there is a vector A, this is vector A, and there is a vector B. Both are perpendicular, right? So A vector and B vector. So A vector plus B vector will be somewhere here, right? This is A vector plus B vector. A vector plus B vector. Fine. Now A vector minus B vector. A vector minus B vector. How to find this? See, this is A vector plus of minus B vector. This is nothing but A vector minus B vector. We cannot subtract two vector, but we can add the negative of second vector. So negative of second vector, this is A vector, right? This is B vector. Negative of second vector will come downwards. Negative of second vector will come downwards, right? So minus B. Now we need to add A vector and minus B vector. For that, what we shall do? Again, we'll use parallelogram law. This is minus B vector. This is resultant. Okay, this is plus B vector. This is minus B vector. This one is resultant, which is A vector minus B vector. Fine. What is given? The vector A is perpendicular to B, component of A vector minus B vector along A vector plus B vector. I want this component along this will be, that means this theta will be how much? If this is phi, this will also be phi only, right? So component, this component of A vector minus B vector along A vector plus B vector. Let us name this. Let us say this is M vector. This is N vector. I want N vector component along M. So that means N cos 2 phi. It will be N cos 2 phi. Okay. Component of N vector along, what is that? Along M vector. This is how we want to find. Now N is already A vector minus B vector. Cos 2 phi. Cos 2 phi, how will you find? Cos 2 theta, right? Cos 2 theta. So we just need to substitute N vector and cos 2 phi. Phi, if you want, you can write as how to one find. Tan phi will be B vector by sorry, A vector, yeah, B vector by A vector. That is tan phi. Okay. This will be M vector. Component of N vector towards M vector. N cos 2 phi. Subject to this, you will get option C. Now coming to question number 2, work done in increasing the size of a soap bubble from a radius of 3 cm to 5 cm is. Now keep in mind, soap bubble has two surfaces. This is soap bubble, right? It has two surfaces. This is one surface, which is outer surface, and there will be another surface, which is inner surface. This is outer, and this one is inner surface. Okay, soap bubble has two surfaces. So what they want, work done in increasing the size of a soap bubble from radius. So R initial is how much? 3 cm, and R final is how much? 5 cm. Is nearly. Surface tension is also given. See, work done equal to surface tension time change in total surface area. So surface tension T, total surface area. So it will be twice, right? Twice of final surface area means pi 4 pi R final whole square minus 4 pi R initial whole square. Okay, final surface area minus initial surface area is change in surface area into 2. Why we are doing? Because there are two surfaces. There are two surfaces into surface tension. This will be worked. Okay, 4 pi surface area of a sphere. Fine. Coming to third question. Third question will be once again. Yeah, a rocket of initial mass 1500 kg, 1500 kg ejects gas at a constant rate of 10 kg per second. So rate of mass is given dm by dt. dm by dt is equal to 10 kg per second. Okay, with a relative velocity. Velocity is equal to 5 kilometer per second. That means 5000 meter per second. Mass of is given. Initial mass 1500 kg. What is the acceleration of the rocket 50 seconds after the blast? Neglecting gravity. Acceleration of the rocket 50 seconds after the blast. Time is given 50 seconds. Yeah. So 50 seconds after the blast, what will be the mass? Say 50 seconds after the blast. See, a rate of mass is given 10 kg per second. Na? So 50 seconds, around 50 kg mass will decrease. 50 kg mass has to decrease. Okay. So in that case, you need to write force equal to V into dmv, dm by dt. And force you should write here as mass times acceleration. Now mass will be what? Mass you should not take the initial mass. Initial mass is 1500 kg. But here, what is the acceleration of the rocket? 50 seconds after the blast. 50 seconds after the blast means after the blast for the next 50 seconds, what will happen? Mass will be decreasing, right? Rate of mass is given 10 kg per second. That means per second 10 kg will decrease. For 50 seconds, 500 kg will decrease. So that mass, final mass you will take. The rate of mass is given, velocity is given, final mass you can find, A will be defined. Fine. Now coming to question number 4. A wooden block with a coin placed on its top. Yeah, it's an interesting question. In fact, this is one of the previous year JE question. What is given here? Most of the students will do mistake in this question. Question number 4. A wooden block with a coin placed on its top floats on the water as shown in the figure. The L and H are shown here. L, this is given L, and this is given H, are shown here. After some time, the coin falls into the water. Then, see if the coin falls into the water. What happened? See, the coin volume is very, very less. Coin volume is very, 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 very less. Okay. So due to the coin, there won't be any rise in water because volume is very, very less. So as the coin volume is very, very less, there won't be any rise in water level. But as the coin has fallen inside the water, mass on the top of the block or cylinder or wooden block will decrease. Mass on the top of the wooden block will decrease. Then what will happen? Wooden block will shift up. Obviously, if something is floating and if I have decreased the mass, it will shift up. Na? If I add mass, it will shift down. So what will happen? Wooden block will shift up. If wooden block will shift up, what will happen? Then again, the water level will decrease. That means H will decrease. H will decrease. And if the wooden block shift ups, L will also decrease. So both H and L will decrease. Option 4 is correct. Yeah. Now question number 5. Question number 5, what is given? 2 blocks of mass 8 kg and 5 kg connected by a heavy rope of mass 3 kg. Rope is there of mass 3 kg. Complete system is accelerated upwards by 10 meter per second square as shown in the figure. the tension at the point P. This is the point P. Tension at the point P they are asking. Okay. So now this is what, this is 8 kg na? So this will be mg. And this will be pseudo force ma. Clear? Now this is what, free body diagram of 8 kg mass. Mg is downwards, pseudo force is also downwards. Clear? And let's say there is some tension T1 upwards. If I draw P, see this hole is 3 kg, right? And this is 5 kg. So I can say total will be 7 kg. P has to hold 7 kg. Sorry, 8 kg. So P is holding how much? 8 kg. I'll just draw it clearly. First, let us draw the free body diagram of 8 kg mass. So let's say this is 8 kg mass. 8 kg. Okay. What is the first force? First force will be mg. Another force will be ma, pseudo force downwards. And let's say there's a tension T, T1 upwards. And there is one more tension. See, 8 kg is attached with a string, right? So there will be a one more tension, T2 downwards. T2 is tension at P. T2 is tension at P. Mg downwards, pseudo force downwards, T2 downwards, T1 upwards. So I can write T1 equal to mg plus ma plus T2. Now similarly, I will draw free body diagram of 8 kg, 3 kg rope and 5 kg mass. Free body diagram of 8 kg. Okay, so let's say this is 8 kg. 8 kg. Now tension will be upwards. It is attached to a rope, na? So let's say this is T2. 8g downwards and 8a also downwards, pseudo force. So T2 and this whole thing is going upwards with 10 meter per second square. So I'm using pseudo force, right? That means I'm solving question with respect to non-inertial flip. T2 equal to 8a plus 8g. T2 will be equal to 8a plus 8g. Fine. Now 8a plus 8g, a is given how much? 10. G is also 10. That means 160. 160 Newton. Okay. 8a plus 8g, right? So a is given 10, a is given 10, g is also 10. So 80 plus 80, 160 Newton. Okay. Next, coming to question number 6. Question number 6. What is given here? A NPN transistor in a common emitter. See students, common emitter is only there in our portion. Only common emitter is there in need portion. Is used as a simple voltage. As a simple voltage with the amplifier collector connected to load resistance RL. Load resistance is output resistance and to the base through a resistance RB. Input resistance is base resistance. Input resistance is base resistance, whereas load resistance is output resistance. The collector emitter voltage 4 volts. This is output voltage. And the base emitter voltage, this is input voltage, is 0.6 volt. Current through collector, this is output current. The current amplification factor beta is 100. Calculate the value of RB. See, beta is equal to, what is that current amplification factor? That means I output by I input. This is current amplification factor, I output by I input. Now current through collector, that means I output is given 4 milliampere by I input. Okay. Calculate the value of RB. What is it? Voltage amplification is what here? I can write V output by V input. Voltage amplification, I can write I output by I input into V is equal to IR, right? R output by R input. Now, what is I output by input? This is beta. Beta and R, this is beta, this is given, these two are given. What is V output? Common emitter, this is output, 4V, 4. V input, 0.6. Okay, equal to beta. Beta is given 100 into R output, R of collector. RB I need to find, right? Yeah, very simply we can find. No need to do all this. I know this given. Beta is given. I will be how much? I will be I input. I input will be 4 milli, 4 into 10 power minus 3 by beta. Beta is 100. Okay. That means 4 into 10 power minus 5. I input is 4 into 10 power minus 5. Now V input equal to I input into R of base. 4 into 10 power minus 3 divided by 100 into R of base. V input is given 0.6. So with this formula you can find RB. 10 power minus 5 is there, na? So this will come 10 power 5, 0.6 into 6 into 10 power 4 by 4 equal to RB. Fine. Next, keep in mind whatever is there in collector side, whatever there is collector side, that is output. Whatever is there in base side, that is input. That's all. Beta is output by input. I output by input. Potential gain is V output by V input. Next, question number 7. A block has been placed on the inclined plane. The slope angle theta of the plane is So block has been placed on an inclined plane. The slope angle theta of the plane is such that the block slides down the plane at a constant speed. Coefficient of kinetic friction is equal to. So constant speed is, that means expression is 0. Mg sine theta should be equal to friction force mu mg cos theta. Now m will cancel, g will cancel. Mu will be how much? Sine by cos tan theta. Option D. Now coming to 8th question, in the given circuit, calculate voltage across A minus B. Voltage across AB, you can see voltage across AB. Now if you see students, there are two PN junction diode. This diode is forward bias, whereas this diode is reverse bias. Reverse bias will act as an open circuit. That means no current will flow through this. If no current flows through this, these two will be in series. So C equivalent will be how much? 1 by C equivalent will be 1 by C plus 1 by C. That means 2 by C. C equivalent will be C by 2. C equivalent I was C by 2. Now what will be charge? C is equal to Q by V. C equal to Q by V. 30. Q is equal to 30 C. Charge I got 30 C. I want potential across C. So C is equal to Q. by V. V is equal to 30 volts. Okay, option C is correct. V is equal to 30 volts. Next, coming to question number 9. A body is projected in such a way that the horizontal range and time of flight both are equal to root 3 by g. The angle of projection will be horizontal range. Horizontal range is what? U square sine 2 theta by g equal to root 3 by g. Both are equal to root 3 by g. Na? Or else directly you can find like this. We know that one formula, h by r equal to tan theta by 4. Time of flight is there, right? Okay. Range is there, only that we can find. Time of flight is what? 2u sine theta by g. This is given root 3 by g. Now, what I can do is, I can just divide. This will get cancelled. G will get cancelled. This will also get cancelled. Sine 2 theta will be 2 sine theta cos theta. So I can get here 2 sine theta cos theta into u equal to 2 sine theta. Correct? This get cancelled. So cos theta is equal to, I got 1 by u. Cos theta, I got 1 by u. So cos theta value I got 1 by u, but u value is not given, right? So u value easily you can find. Gg will get cancelled. I'll write here u square. This I can write as 2 sine theta cos theta, 2 sine theta cos theta or u value directly you can write. U is what? U is equal to 1 by cos theta. U square will be 1 by cos square theta. U square will be 1 by cos square theta into sine 2 theta, 2 sine theta cos theta. Gg will cancel. This is root 3. So 1 cos theta, cos square cancel. Then sine by cos is tan. Tan theta is equal to root 3 by 2. Theta is equal to tan inverse root 3 by 2. Okay, theta will be tan inverse root 3 by 2. U value I got, I'll just substitute U value here. Okay. Next, coming to question number 10. Tan inverse root 3 by 2. Question number 10. Activity of 1 milligram of an element is 1.2 10 power 3 disintegration per second. What is activity? Activity is equal to lambda times n. The activity of 1 gram of the same element will be, see, 1 milligram of element is this much. See, mass is given. Let us say mass of one radioactive particle is m1. Mass of one radioactive particle is m1. So in 1 milligram, let us say n number of particles are there. N number of particles in 1 milligram. N1 number. So it is weighing how much? 1.2 into 10 power 3. Okay. Now in gram, how many? So in gram, more particles will be there. Na? In 1 milligram, this many particles. This weighing is this much. 10 power 3 if I multiply, then I will get in 1 gram, right? So mass will also increase. If mass will increase, then the activity will also increase, correct? So in that case, mass will be how much? Mass will be how much? M2 will be, because now N2 will also increase. In 1 gram, there will be more number of particles. So it will be 1.2 into 10 power 6. This will be M2. Lambda remains the same. We are talking about the same particles. So R will also be 1.2 into 10 power 6. Option C. Next, question number 11. What is given here? Two persons A and B running on a track in the same direction observe a car. A says that the car is moving in east direction and B says the car is moving in north direction, but contradict the direction. They contradict direction but says the magnitude is same. If the speed of B is double that of speed of A, the true direction of the car will be. Very nice question. Two persons A and B are there running on a track in the same direction. Observe a car. So let us say there is a track. So there are two persons A and B running on a track in the same direction. So this is A and this is B. They are running on a track in the same direction. Observe a car. A says that the car is moving in east direction. Car is moving in east direction. That means with respect to A, velocity of car with respect to A equal to V in east direction. Then B says that car is moving in north direction. Velocity of car with respect to B, V north direction. They quantity direction in magnitude, but say magnitude is same. Magnitude is same. If the speed of B is double that of speed of A, the velocity of V equal to twice of velocity of A, double of velocity of A. Then the true direction of car will be, what will be the true direction of the car? Okay. Now listen. How to find the true direction of the car? Now, according to A, it is moving in, what is it? East direction. So I just make the direction first. So this is east, west, north, south. So velocity of car with respect to A, that means velocity of car minus velocity of A will be equal to V east direction. Velocity of car minus velocity of B will be equal to V in north direction. Okay. But A and B, they both are moving in same direction. Same direction. A and B are moving in same direction. So I can write as velocity of car minus velocity of A. So what is velocity of A? Velocity of A I can write as velocity of car minus V into east direction. Yeah. So what will happen here? True direction of the car will be. One second, I'll just erase it so that I make some space. Equal to V. This is east, this one is north. Just subtract it. Okay, you just subtract it. What will happen? This vector will cancel. VB vector minus VA vector. VB vector minus VA vector will be equal to VB vector minus VA vector will be equal to V times what? North, na? North. You can write V times east, V I cap minus V j cap. So north times east minus V j cap, right? Minus of V j cap. V I cap. This is V I cap. This is V I cap. Minus of V j cap. Minus of V j cap will be downwards. Na? We can add both. We can add both. This will be this. V I cap minus of V j cap. Fine. This is the net direction. Net direction in which direction? Southeast. Southeast. Option B. V I cap minus of V j cap. So this will be southeast. Now coming to question number 12. Question number 12. What is given? The radius of nucleus. The radius of nucleus of oxygen 816 is 3 into 10 power minus 15 meter. Density in kg per meter cube will be about. Okay. Mass is how much? Mass is 16 AMU. So that means 16 into 1.66 into 10 power minus 27 or 27 kg. And radius is given. Or you can write directly, we can find density. See, mass is there and dense volume. Radius equal to, I know that R naught A power 1 by 3. Okay. Density is mass by volume. Volume is what? 4 by 3 pi R cube. Mass is given 4 by 3 pi. Radius is already given. No to substitute here. 3 into 10 power minus 15. Okay. 4 by 3 into this is get cancelled. 4 pi into 10 power minus 15. Mass is this one. Mass you put in kg. Substitute it, you will get answer. It's T. Now question number 13. What is given here? A ball moving with the velocity v strikes a wall moving towards the ball with the velocity. Okay. Collision based problem. Question number 13. A ball moving with the velocity v strikes a wall. So there will be a wall. Ball is there moving with velocity v. Strikes a wall moving towards the ball with the velocity u. Now wall is not at rest, it is moving with u. And elastic impact lasts for t seconds. Then the mean elastic force acting on the ball is elastic force they are asking. First elastic impact is that. What is force? dmv by dt. dmv by dt. Okay. Ball moving with velocity v strikes a wall moving towards the ball with a velocity u. And elastic impact lasts for t seconds. Now elastic collision is happening. Okay. T seconds. Then the mean elastic force acting on the ball is, so mass of the ball is given m. I want mean elastic force acting on ball, so that means dmv by dt. Change in velocity I need to find. Mass is constant, so m, this is dv by dt. Initial velocity is v, final velocity will be how much we need to find it. Okay. Mass of the wall is not given. We'll consider that mass of the wall is very, very high. So elastic collision is there, right? Elastic collision means what? Momentum is conserved and even kinetic energy is also conserved. elastic collision, both are conserved, right? So I can get right. Yeah, now enough space. So now initial momentum is how much? M into V plus, let's say this is M dash, this is V I cap na, M dash into U minus I cap. After elastic collision, what will happen? Momentum is conserved, right? So let's say this is M into V1 vector plus M dash into V2 vector. I need to find V1 vector. Okay, so initial velocity is V. This is U. What about V2? I need to find V1 and V2. How to find? Kinetic energy is conserved, you can say, or else you can find that is V1 equal to, let's say this is V1, this is V2. M1 plus M2, M1 plus M2 plus M1 plus M2, this is M1 plus M2. U1, U1, U2, U2, M1 minus E M2, 1 plus E M2, 1 plus E M1. This becomes M2 minus E M1. Now, with this formula, what we can do is we can find the what's that? E is given what? Elastic collision. E is equal to 1. Substitute E equal to 1 in throughout the equation. Okay, we need to substitute E equal to 1. Now, if you see, say let's say M1 is M, M2 is M dash. M1 is M, M2 is M dash. Now M2 will be very high, na? M2 will be very high. So M1 is M, this becomes M1 minus M2, right? M2 is very high. And here, this is M2. Okay, this is M2. So M2 is very high. So in addition and subtraction, we can neglect M2. Okay, with this we can find what? V1. What is V1? V1 is the velocity of the ball. V1 is the velocity of the ball. Now, once we got V1, we need to find change in momentum. Initial velocity is U. So initial velocity is V. So it will be M into change in momentum. This becomes V. Final velocity V1 vector minus V by time. Time is given t seconds. We need to find V1 from this formula. Put E equal to 1. Okay, next question. Coming to question number 14. Which of the following statement is wrong? De Broglie. 14. Which of the following statement is wrong? De Broglie waves are probability waves. De Broglie wavelength of a moving particle is inversely proportional to momentum. Yes. Wave nature is associated with atomic particles only. No, not like that. This is wrong. Wave nature is not only associated with atomic particle but bit larger also, but wavelength will decrease. Next, 15th. A block of mass m moving with velocity u, it hits a hill it meets a block of mass m moving with velocity u. It meets a hill of mass 3m and height h, and it can also move along the plane. So there's a block, mass is given m, block of mass m moving with velocity u. It meets a hill of mass 3m and height h that can also move along the plane. Okay, the block begins to slide up the hill. If the hill is initially at rest, the value of E provides the maximum velocity of the hill. The value of U provides the maximum velocity of the hill. Assume for the surface of frictions. Hill here it is given, nothing but an incline. Block of mass m moving with velocity u. Okay, it meets the hill of mass 3m and height h that can also move along the plane. This can also move. Okay, block begins to slide up the hill. Block begins to slide up the hill. If the hill is initially at rest, initial velocity of the hill is at rest, then what value of u provides the maximum velocity of the hill? Assume all the surfaces are frictionless. All the surfaces are frictionless. Okay, so if all the surfaces are frictionless, what will happen? Energy will be conserved, right? Energy will be conserved. And height h can also move along the plane. Block begins to slide up a hill. Say if block will slide up a hill, what will happen? If the block will slide up a hill, the velocity will keep on decreasing. Velocity will keep on decreasing because the kinetic energy is being converted into potential energy. But as this block will try to hit this 3m block, some of its kinetic energy will be given to this. Both will be moving in the with same velocity, right? Both are moving with the same velocity. So you can write like this. Initial kinetic energy will be how much? Half mu square plus 0 should be equal to final kinetic energy will be half m is how much here? 3m v square What value of u provides the maximum velocity of the hill? I need to find value of u. Yes. See, once it has reached the maximum, the mass m reaches the maximum height, some of its velocity will be used to gain, some of its velocity will be used to gain potential energy. So conservation of energy I'm doing. So some, yeah, potential energy, I can add plus m gh plus half m v square. And to find m will get cancelled. Okay. I can write into 2 divided by 2. So 4. So all these 2 will get cancelled. So this becomes u square equal to 3v square plus this one is v square, 4v square plus 2gh 2gh Now V square, V I need to find. V I need to find. Sorry, student, there's a mistake here. V won't be there. Yeah, so directly we can use conservation of energy. So first is half m u square equal to half m. It will be 4m. 4m. Let's say v whole square. So with this we can find v. Once I got v, then I can write m, that half m v square equal to mgh. So v square is equal to 2gh. Okay. Substitute this v square over here, then solve. We'll get h will be equal, u will be equal to root over 8gh. 4 into 2, this becomes 8. Half of will get cancelled. Yeah. Next, coming to next question. Question number 16. The light of wavelength 300 nanometer falls on a photoelectric emitter. Photoelectrons are liberated of zero kinetic energy. For another emitter, however, light of 600 nanometer wavelength is sufficient to create photo emission. What is the ratio work function of the two emitters? Work function. Light of wavelength 300 nanometer falls on a photoelectron. So that means hc by lambda 1. K is 0 na, equal to 5. With zero kinetic energy, right? So 5, 1. For another emitter, however, light of 600 nanometer wavelength is sufficient to create photo emission. That means hc by lambda 2 equal to 5. What is the ratio work function of the two emitters? SCS will get cancelled. This becomes lambda 2 by lambda 1. Lambda 2 by lambda 1. That means 600 by 300. 2 by 1. Option B is correct. Next, coming to question number 17. A pump motor is used to deliver water at a certain rate from a given pipe. Okay, to obtain thrice as much water from the pipe in the same time, power of the motor has to be increased. Pump motors deliver water at a certain rate from a given pipe. To obtain thrice as much water from the pipe in the same time, power of the motor has to be increased. How many times? Okay. Power is equal to what? Work done by time. Work done is what here? You can say dmv by dt, rate of mass, or force time velocity. F dot s, power of force time velocity. Now see, pump motor, that is, I know that rate for a given pipe. So there is a given pipe, okay. To obtain thrice as much water from the pipe. So from the pipe is area is constant. So rate of mass, rate is equal to A into V1, A into V1, which is nothing but Q, which is equal to M by T. So M I can write what? Density is mass by volume. Density is mass by volume. So density is what? I can write mass equal to density into volume, which is A into L. So density volume A into L by T. This is what here? Rho V L by T is V into A. Okay, rho VA. This is the rate of mass, na? M by T. So now what they are saying here, to obtain thrice as much water from the pipe, mass is thrice as much. Okay, mass is thrice. V is velocity. Okay. V is velocity. So A is obviously A. Same time, power of the motor has to increase. See, if mass is thrice, that means velocity should also be increased, right? Velocity should also be increased. I can write here A1, that means A into V1, or M1 by T. M1 by T is Q1, first discharge. Okay, Q2 will be how much? Mass is thrice, 3 M1 by T. At the same time, right? So rate of mass is 3 M1 by T. Now velocity is there. F d V is out, M by dt. Yeah, already V is there. M by dt is rho VA. So I can write rho V cube A. Rho V cube A. dm by dt is rho VA. So rho V cube A. V cube is there. So velocity should be thrice. Velocity should be thrice to obtain 3 times the mass at the same time. Velocity should be thrice. So velocity is thrice means power should be here. P is directly proportional to V cube. So power should be 27 times. Okay. Now question number 18. Question number 18. Magnifying power. Magnifying power of astronomical telescope for normal adjustment is 5. The distance between lens is 24 centimeter. Focal length of the lenses are. Normal adjustment is what? Normal adjustment is final image is at infinite. Okay, so magnifying power is equal to beta. Beta, that is what is that? Angle subtended by eyepiece divided by angle subtended by field length. Nothing but objective length. Beta will be what? Here it should be f naught. Na? Eyepiece fe minus of fe by f. This is given 5. The distance between the lens is 24 centimeter. That means fe plus f naught is given 24. Fe by f naught is given 5. Easily we can find fe is equal to 5 f naught. So 6 f naught is equal to 24. 6, 4, 24. One is 4 centimeter, other one is. So fe is equal to 5 f naught. Correct. So plus this becomes 6 f naught. 6 f naught is equal to 24. F naught is equal to 4 centimeter. F naught is 4. Then fe will be equal to 20 centimeter. Should be correct. Okay. Next, directly formula based question. Coming to question number 20. Sorry, 19. So bubble blue color due to interference. Interference from thin surface. The concept is interference from thin surface. Question number 20. The near point of a person is 50 centimeter. What is the power of lens required to enable the person to read clearly a book held at 15 centimeter? Near point of the person is 50 centimeter. Okay, what is the power of the lens required to enable the person to read clearly a book held at u is equal to given minus 25 centimeter? V will be equal to minus 50 centimeter. Focal length amplified. Once you find focal length, P is equal to 1 by F. Fine. Next, question number 21. Question number 21. A Young's double-slit experiment, the phase difference between two waves reaching at the location of a third dark fringe. Phase difference, third dark fringe. Phase difference between two waves reaching the location of the third dark fringe. Location of third dark fringe will be how much? See, for dark fringe x equal to what? We know that. See, path difference equal to what? Path difference equal to x d by d. So now x small d by d. X small d by d. This is the path difference general formula. For dark fringe, what is I can equate this with lambda by 2 into 2n minus 1. Lambda by 2 into 2n minus 1. This is what path difference. Okay. X I can find as x equal to d lambda by 2d into 2n minus 1. Now n is what? Third fringe, no? Third dark fringe. 6 minus 1, 5. X equal to 5 lambda d by 2d. At this point, what I want? The phase difference between, so this is the path difference, no? This is x. The phase difference between the two waves reaching the location of the third dark fringe. Okay, third dark fringe, directly we can find path difference. Third dark fringe, directly we can find path difference. Path difference will be 4 minus 1, 5. 5 lambda by 2. Then we can use 5 by 2 pi equal to lambda, delta by lambda equal to delta t by t. So 5, this is by 2 pi. This is 5 lambda by 2. This is lambda. Cancel. Lambda, lambda cancel. 5 will be 5 pi. Option C. Okay. Now coming to question number 22. (22) 6 resistors each of value 6 ohm are connected between points A, B, C as shown in the figure. If R1, R2, R3, if R1, R2, R3 are the net resistance between A, B and BC respectively, R1, R2 is to R2 is to R3 equal to. R1 is a what? R1 is net resistance. R2 and R3 are the net resistance between A and B. Between A and B, this is what R1 equal to R only, na? R2 net resistance between B and C. B and C, this becomes R by 2. R by 2. And A and C, this becomes R by 3. I just need to find the ratio of R1, R2, R3. R will get cancelled. So it becomes 6 is to 3 is to 2. R value is also given, right? R value is also based on that you have to find. Okay, between A and C, right? Between A and C. That means potential is between A and C. Don't name this like this. This is R1 dash, let's say R2 dash, equal to R by 3. Between A and C, this will be in parallel. This will be R by 2. This is R. These two will be in series. Like that, you have to find R equivalent. After that, you have to find a ratio. See, while you're finding between A and C, These three will be in parallel. These two will be in series, and these two will be in parallel, and this will be in series. So R by 2 plus R. Again, that will be parallel with R by 3. Clear? Like that you have to solve for each cases. Fine. Next. Coming to question number 23. The spherical shell first rolls and then slips down the inclined plane. The ratio of its acceleration in two cases. First it will roll and slips down. Spherical shell. The ratio of its acceleration in the two cases will be. When rolls, that means A is equal to G sine theta by 1 plus C. If it is slips down, A will be equal to G sine theta. The ratio of its acceleration in two cases, A1 by A2. G sine G cancel. It will be 1 by 1 plus C. C is given how much? Spherical shell. Shell means it should be spherical shell, right? C is how much? What is C? C is coefficient. For shell, it is 2 by 3 mr square. For solid sphere, it is 2 by 5 mr square. Solid, it is so this becomes C. This is C, 2 by 3. So this becomes 5. 3 will go up. 3. Option B. Next, question 24. A voltmeter of resistance 28 ohm reads the voltage across the terminals of an old dry cell to be 1.40 volts. Voltmeter of resistance. G is given. 280 ohm reads a voltage across terminals of an old dry cell. 140 volts. Okay. If the potentiometer reads the voltage equal to 1.55 volt, that means EMF is given how much? 1.55 volts. To draw maximum power from the battery, the load resistance must have the value. Yes. So I'll just write like this. E is given as 1.55. Voltmeter is reading 280 volts. So voltmeter is reading 140 volts. Voltmeter, how it will read? See, if this is a battery, okay, and this is G, right? 280. It will read potential difference V. Okay. So 1.40. Potential difference is given 1.40. So internal resistance is there. What they're asking to draw maximum power from the battery, the load resistance must have the value. So let's say there is load resistance. Now apply Kirchhoff's law. What will get here? I into R minus I into small r plus E, that is 1.55, should be equal to 0. Okay. With this, what is V? V is V, I can write as E here. Here, let's say I dash into 280 minus I dash into small r plus E. This should be equal to 140. With this, I can get I dash and smaller. Once I got smaller, I can use this. With it, I can get I. Once I got I, power will be equal to I square R equivalent. R equivalent will be small r plus capital. So this is concept from discharging of cell and along with what is it, galvanometer. Let's come to question number 25. A chain couples and rotates two wheels in a bicycle. The radius of bigger and smaller wheels are 0.5 and 1 respectively. The bigger wheel rotates at a rate of 200 rotations per minute. Then the rate of rotation of smaller wheel will be. Somewhat less. Okay, the chain couples and rotates two wheels in a bicycle. Okay, the radius of bigger and smaller wheels. This is bigger wheels is 0.5, smaller wheels is 0.1 respectively. Bigger wheel rotates at the rate of rotation per minute. Omega is given. Now V should be same. So V should be same. V is equal to R omega. That means R1 omega 1 is equal to R2 omega 2. V should be same. 0.5 into omega is given how much? 200 rotations per minute. 200 equal to R2 0.1 into omega 2. So this becomes 5 into 2, 10,000 rotations. Tangential velocity should be same. Option A is correct. Okay. Coming to question number 26. A body is projected vertically upwards from the surface of Earth with velocity equal to half the escape velocity. If r is the radius of Earth, the maximum height attained by the body. Half the this is velocity is given how much? Escape velocity by 2. Maximum height which can be attained. That means final velocity is 0. Let us say this one is h. It is conservation of total energy. That means this will be half into m into v square minus g m by r equal to, here kinetic energy is 0, it becomes minus g m by r plus h. I want h. We need to substitute escape velocity formula. What is it? Root over 2gm by r. Okay, 2gm by r. You can substitute v, ve, everything will be in terms of gm by r. Then gmm will cancel, r plus h will be there. With that, we can find h. We just need to substitute ve over here. Okay, next, coming to question number 27. During a adiabatic process, the increase in volume is associated with which of the following possibilities with respect to pressure and temperature? Adiabatic process, what is constant? Heat is constant. Change in heat is 0. The increase in volume is associated with which of the following possibilities with respect to pressure and temperature? That means if volume will increase, then pressure will decrease or increase, temperature will decrease or increase. See, it's an adiabatic process. Now, I'm not providing any kind of heat. In that case, volume is increasing. So obviously pressure will decrease. Okay, if volume is, let's say there's a system. Here I'm not providing any heat and I am increasing the volume. So what will happen? Pressure will decrease. Pressure will decrease because the volume is much higher now. Temperature will decrease. Temperature will also decrease. Why temperature will decrease? Because the kinetic energy, the net kinetic energy of the gas molecules will decrease now. Volume has increased, right? So net kinetic energy will decrease. So temperature will further decrease. Or else you can solve with v power gamma equal to constant. Okay. VB power gamma is equal to constant, where gamma is adaptive constant. And with this itself, we can say that, see, gamma is a constant. With this itself, we can say that pressure and volume are, what is it, inversely proportional. Yeah, option B is correct. Now question number 28. Consider a satellite orbiting in a Earth as shown in the figure below. LA and LP represent the angular momentum of a satellite about the Earth when at the aphelion and perihelion, respectively. Perihelion means it's near to the Earth. Yeah, and aphelion means it is away from, far away from the Earth. Consider the following relations. LA equal to LP, and whether angular momentum is conserved. LA is negative of LP. R into LA equal to R into LP. They are asking which of the following relation are true. So option A, option B, C, but the option A is saying only one. See, in this, angular momentum will be conserved. Angular momentum will be conserved because there is no net torque. Okay. Here, angular momentum is not in negative direction. Angular momentum is an axial vector. Its direction is not changing. Although momentum direction is changing, but angular momentum direction is not changing. It's the axial vector. Okay, this is wrong, and this is obviously it is wrong. So option only first one is correct. Now coming to the next question. Question number 29. HC, HK, HF are heat required to rise the temperature of 1 gram of water by 1 degree in Celsius, Kelvin, Fahrenheit. Temperature scale respectively. Then rise the temperature of 1 gram of water by 1 degree. So in Kelvin and Celsius, difference in temperature remains same, right? In Kelvin and Celsius, which will be greater than Fahrenheit. Yes. 29. Capacitor is first charged by connecting across 200 volts battery, and it is allowed to get discharged through a resistor R. The figure shows an experimental plot discharging of capacitor. Value of R is log E square is log 2 base is given 0.7. So this is a capacitor of capacitance is first charged by connecting across a 200 volts battery, then it is allowed to get discharged. C is equal to what? Q by V. So V is given as 200. Volt, this is given time, is VT relation is given. Capacitor is first charged by connecting a 200 volt battery. So Q will be how much? 200. Q naught will be 200. Q naught, I can say 200 C. Then it's allowed to get discharged to a resistor R. So now what I'm doing is I am allowing passing a resistor R. The figure shows an experimental plot through the capacitor. Slope also we can find here. Slope of V and T curve we can find. Then with discharging of capacitor, Q is equal to Q naught 1 minus e power T by 2. Okay, with this formula we can find. Next, coming to question number 31. Four spheres A, B, C, D are of same radius but made of different metals. Their densities are in the ratio 6:3:4:5, and specific heat are in the ratio 2:5:4:6. These are initially kept at the same temperature and placed in the same surrounding. The spheres which has the slowest rate of cooling. See, a rate of cooling will be directly proportional to the surface area. Okay, rate of cooling will be directly proportional to the surface area because heat can radiate much faster there. Rate four space A, B, C, D are there. A, B, C, and D of same radius but different, but made of different metals. So same radius, surface area is same, fine. Made of different metals. Their densities are in ratio 6, 3, 4, 5. Specific heat are in the ratio 2, 5, 4, 6. So highest specific heat is given 6, right? If specific heat is more, that means it can radiate larger heat, right? At the same time, if specific heat is more, it can radiate larger heat at the same time. That means it will cool faster. The sphere which has the slowest specific heat is 6, right? Slowest rate of 2, 5, 4, and 6, right? And the specific heat are in the ratio 2, 5, 4, and 6. Specific heat is given 6. It's the highest among all the spheres. Specific heat of D is the highest. So obviously what will happen, it will cool down slowly, cool down slowly. Yes. Option C. Now coming to question number 32. Two identical incandescent light bulb are connected as shown in the figure. The circuit is connected to an AC voltage source of variable frequency. Then read the following observations. Observation A, both bulbs will glow with same brightness on frequency f is equal to 2 pi root over LC. This is what frequency? This is resonance frequency, right? That is potential across. Anyhow, here potential is same. Okay. Bulb P1 will glow with more brightness than bulb 2 and frequency is lesser than resonating frequency. Both observations are correct. Both observations is incorrect. Observation A is correct, but observation B is incorrect. Observation A is correct, but observation B is incorrect. Yeah. Now what is given here? Both the bulbs P1, both bulbs B1 will glow the same brightness or frequency. Yes, first one is correct. Now second one is wrong because bulb B1 will glow with more brightness than bulb B2. No, B2. See, if while resulting frequency, if frequency is lesser than resulting frequency, it will be more capacitive. Frequency is lesser, right? Omega L, this is 1 by omega C. This is what XL, this is XC. Frequency is lesser than omega, it will be more capacitive. Okay, bulb P1 will glow with more brightness. P1 will go with resistance is higher, it will grow with less brightness. The resistance is higher, right? Omega is less, XC will be high. Next, coming to question number 33, RMS velocity of a gas at a certain temperature is 2 times than that of an oxygen molecule at that temperature. Gas can be. RMS velocity of a gas at a certain temperature is 2 times that of an oxygen molecule at that. VRMS is what? Root over 3 RK by M. Equate with what? Oxygen molecule. At that temperature is same. Molecular mass of oxygen molecule is you can say 32. Next, question number 34. The LCR circuit is connected to an alternating EMF. EMF is given volts. Then I is given ampere current flow in the circuit. The reactance of is. Reactance means what? Z. See, this is what E naught. This one is I naught. I can write as E naught is equal to I naught times Z. E naught is 200 equal to I naught. I naught is 2 into Z. Z equal to 50. Option A is correct. Coming to question number 35. An ambulance blows siren of frequency 700 Hz is moving towards a vertical wall with velocity 2 meter per second. Velocity of sound is 352 meter per second. Frequency of reflected sound heard by the driver will be. So there is a vertical wall. So there is an ambulance blowing a siren of 700 Hz. F naught is given 700. It's moving towards a vertical wall with velocity v of source is given 2 meter per second. Velocity of sound is is given just v, right? 352. Frequency of related sound heard by the driver. Heard by the driver. So driver itself is the observer. So velocity of observer is also 2 meter per second. Okay. So observer is moving in this direction. Source is moving in opposite direction. Because the reflected wave, observer is listening to the reflected wave, right? So this is observer, this is source. I can write F is equal to F naught V, this is V naught V Vs. So plus this becomes minus. V naught is given 2, Vs is also given 2, V is given 352, this is 352. F naught is given, I need to find F. Okay, just solve this, you will get the answer. This is from Doppler's effect. Now coming to question number 36. A current through is 6 millihenry inductor as shown in the following graph. Induced EMF at t equal to 4 millisecond will be. Four millisecond. You can find the, what is this? This is 5,5. This will be 6,0. You can find the slope. Slope is what? Di by dt equal to y2 minus y1. Y2 minus y1 will be 0 minus 5 by x2 minus x1, 6 minus 5 1. So current is decreasing, right? Current is decreasing. E is equal to minus L di by dt. L is 6 millihenry. Fine. Next, coming to question 37. Which is the following function of time represents SHM? Now, what is the concept here? SHM means A should be equal to minus omega square x. A is equal to minus omega square x. You should take this, all this as y. dy by dt will do, then you'll get v, then dv by dt will get a. Whichever function qualifies this statement, that is the SHM. A will be correct answer. Next, question 38. A working transistor with its 3 legs marked PQR is tested using a multimeter. No conduction is found between P and Q. By connecting the common terminal of the multimeter to R and other positive terminal to P and Q, some resistance is seen in the multimeter. Which the following is true for the transistor? What is given here? A working transistor with 3 legs marked PQR. So there is a transistor, let's say, somewhat like this. PQR is tested using a multimeter. No conduction is found between P and Q. That means one is reverse bias. By connecting the common terminal, common negative terminal to a multimeter to R and the other positive terminal to P and Q, some resistance is seen in the multimeter. Okay, which of the following is true for the transistor? So let's say this is NPN transistor. This is P, Q, and R. This is P, Q, and R. Stress is using a multimeter. No conditions found between P and Q. P and Q by connecting the common negative terminal of a multimeter to R and the other positive terminal. I'm connecting here negative to P and Q. This is positive, this is positive. Which of the following is true? Some resistance is in the multimeter. Now here it is. Again. This is forward bias. Clear? So obviously this will be an NPN transistor. Next, 39. An open pipe is suddenly closed with the result that the second overtone of the closed pipe is found to the higher in frequency of 100 Hz than the first overtone of the organ pipe. The fundamental frequency of open pipe will be. Open pipe is suddenly closed with the result that the second overtone of a closed pipe Now what is given? Open pipe is suddenly closed with the result that the second overtone of a closed pipe is found to be higher in frequency by 100 Hz. The open pipe is suddenly closed. First there was open pipe, now it is suddenly closed. It became a closed pipe. That the second overtone of the closed pipe, is found to be higher in frequency by 100 Hz. So length of the pipe is same. Now I am just closing it, right? Then the first overtone of the organ pipe, the fundamental frequency of first of the organ pipe. Second overtone of the closed pipe is found to be higher in frequency by 100 Hz than the first overtone of the organ pipe. First overtone is what here? In case of open pipe, NV by 2L. N is varying from 1, 2, 3, 4, so on. Here it will be F is equal to NV by 4L. N is varying from 1, 3, 5, so on. Okay, what they are saying, the second overtone of the closed pipe. Second overtone is, this is first overtone, this is second overtone, 5B by 4L. Okay, is found to be higher in frequency by 100 Hz than the first overtone of the organ pipe. 100 Hz than the first overtone of the organ pipe. That is here will be 2, right? 2V by 2L. This is, let's say, F1. This is, let's say, F2, right? Now what is given here? F2 is higher by 100. That means F2 minus F1 equal to 100. They are asking V by 2L. They are asking V by 2L. So this becomes, I can write into 2 into 2. So 4B by 4v by 4l, or v by l. V by l is what? F1. This is F2, 5v by 4l minus 4v by 4l equal to 100. So v by 4l, right? This becomes v by 4l equal to 100. Fundamental frequency of the open pipe. Fundamental frequency means what? V by 2L I want. V by 2L, right? So I can write this one as, if I do into 2 both sides, I'll get V by 2L. So V by 2L will be 200. Option D is correct. Nice question. Question number 40. A square current carrying loop is placed in uniform magnetic field if the magnetic force on one arm of a loop is F. Here there is a printing mistake. There should be F vector. Then the net magnetic force on the remaining 3 arms. So there is a square loop, right? Placed in uniform magnetic field if the magnetic force on one arm of the loop is F vector. Let's say F vector. All the other 3 should be minus F vector, so the net force is 0. Okay, net force experienced by a current carrying loop in extra magnetic field should be 0. So your answer should be D. If this is F vector, other should be minus F vector. Okay. Next, coming to question number 41. The transverse sinusoidal wave of amplitude A, wavelength lambda and frequency n is traveling on a stretched string. Okay, the maximum speed of any point on the string is v by 10, where v is the speed of propagation of wave. If v equal to 10 power minus 3 meter per second, then n is given by the transverse sinusoidal wave of amplitude A, wavelength lambda, frequency n is traveling in a stretched string. The maximum speed of any point on the string is v by 10, where v is the speed of propagation of the wave. Yes. See, in a wave, particle will do SHM. Whereas wave will move forward. V is the propagation of a wave. If v equal to 10 power minus 3 meter per second, then n is given by frequency they're asking. V max is what? V max is omega times A. Na? Omega times A. V max is given V by 10. V by 10 equal to omega times A. And what is V? 10 power minus 3. That means 10 power minus 4 equal to omega times A. A is amplitude. Amplitude is small a. Okay, amplitude is small a. N is what? Frequency they are asking. Omega will be 10 power minus 4, right? V is given 10 power minus 3 seconds. N is given by V max. Time period is what? 2 pi by omega here. So 1 by time period, nothing but frequency will be omega by 2 pi. Yes, there's something missing here. A should be 10 power minus 1. Amplitude should be given. Some amplitude value should be given. Okay, with this, if I substitute here omega is what here? 10 power minus 4 by this is 2 pi into A. A value should be given here. Only then we will get. Okay. Yeah. Next question number 42. A dip needle lies initially in the matic meridian when T1 shows an angle of dip theta at a place. The dip circle is rotated through an angle vertical plane, then it shows an angle of dip theta dash, then theta dash by theta. There is a printing mistake here. There is a printing mistake in 42. They have not given alpha here. Okay, alpha is not given here. Question 43. The diagram below shows the propagation of wave. Which point are in the same phase? Same phase is what? It's F and G. Where is F? This is F. G is here. See, same phase means if one object, one point is going down, other point should also go down. Okay. Here, F and G, whether these are in the same phase? No. B and F are in same phase. B and F are in same phase. So option D is correct. 44. 2 point charges are kept in a certain distance from one another. The graph represents the variation of potential along the straight line connecting the two charges. Q and QB both are positive. Connecting the two charges, right? This is QA, this is Q3. Here, potential is very high. The potential is very low. Okay. So option 2, Q and QB both are negative, and QA is lesser than QB. Both charges are positive. QA is greater than QB. Both charges have the opposite nature. QA is lesser than QB. See here, potential near to Q3, potential is negative. Okay, whereas near to QA, potential is positive. This shows that both are of opposite nature. So first two are wrong. C and D, either C and D will be correct. Now here, if you see, the potential is much higher. Positive potential is much higher when compared to negative. So here, positive charge is much greater. Magnitude of positive charge is much greater. C is correct. 44. Coming to 45. In a certain region, a uniform field E vector is equal to Ex I cap exists. If a small circle is drawn with the origin at the center plus the axis at a, 0. So I need to draw an axis here. Fine. Next, E is given Ex I cap. Small circle is drawn with the origin at the center, cutting the axis at a, 0. So there is a circle, let's say. Fine. What are the points here? A is a, 0. That means this is A. B is 0, a. C is minus a, 0. This is B. This is C. This is D. 0, minus a. The potential at point A, B, C, D are B. Okay, respectively. Then electric field is along I cap, right? So here potential at B and D should be same. B and D should be same. So this is wrong. And potential decreases in the direction of electric field. That means at A, potential will be lesser than D and C. C will be highest. B should be correct. Potential decreases in the direction of electric field. Clear? coming to next. I think this was last. Yeah. So that's all for today's students. Thank you. See you in the next class. All the best for the next test. Okay. Thank you.